Hello, BS and BFST, you're welcome. This time we are looking at analysis of variancy, or what is commonly known as ANOVA. So in the previous topic, we looked at comparing uh, two means, or testing for the difference between two means, and we used both the T and Z tests, but somewhere we also used the F test to compare variances. In ANOVA, we are going to be using the F test to compare analysis of variancy, and also this is used when we are looking at testing the difference between or for more than three or more means. So since the F-test for that case was equivalent to the T-test, we use the T-test instead of the F-test when we only have two means. However, when there are more than two, in case there are three and more, we use the F-test. For example, if a researcher is interested in finding out the means of time it takes three groups of students to solve a computer program using Fortran, BASIC, and Pascal are different. So here the researcher uses the analysis of variance techniques, and the Z and T tests are not applicable. So for three groups, the F-test can only show that there is a difference among the means. However, it doesn't exactly tell where the difference lies. So it's always advisable to go further and use other tests, such as the Shafi and Turkey, to find where the difference exactly lies. So in a situation, for example, in the example we have here where a researcher is interested in finding the means students take to solve a computer problem using the different languages. So here we have one variable, which is a computer language, and that is what we call a one-way ANOVA, or one-way analysis of variable. But in a scenario where we have more than one variable of interest, for example, when we are looking at computer language, and maybe where the student has a mathematical background, there we have two variables under study, and such a study is termed a two-way analysis, or such a test is a two-way analysis of variance, or two-way ANOVA. So assumptions of the F-test: the populations from which the samples got must be normally or approximately normally distributed. The samples must be independent of one another, and the variances of the population should be equal. So even when we are comparing means, for the F-test we use variances instead of the means. So the two different estimates of a population variance are always made. The first one is the between group variance, and this involves finding the variance of the means. And then the second estimate is the variance within group, or the within group variance. And here we compute the variance using all data, and this is not always affected by the differences in the means. So if there are no differences in the means, the between group variance estimate will be approximately equal to the within group variance, and the test value will be approximately 1, and in that case we do not reject the null hypothesis. However, when the means differ, or when the between group variance is greater than or much greater than the within group variance, the F-test will also be significantly greater than 1, and the null hypothesis for that case will be rejected. So like in the previous tests, still here we have the null hypothesis as the means being equal, and then the alternative will be that one of the means is at least different. So we also use degrees of freedom, and for the F-test we have the degrees of freedom of the numerator, and for this specific test the degrees of freedom of the numerator equal to k minus 1, where k are the number of groups, and then the degrees of freedom of denominator, the total population minus the number of groups. So we also need to know that the sample sizes do not have to be equal, and the F-test to compare the means is always a right-tailed test. So the procedure for finding the test value, or the F-test value for analysis of variance, We start by stating the hypothesis and identifying the claim. We find the critical value in the F table, and then compute the test value and compare it to the critical value. So these are the processes or the procedures for finding the test value. So that to get the test value, we find the mean and variance of each sample. Then we find the grand mean. We find the between group variance, which is given by the summation of the sample size times the square of the difference between the individual means and the grand mean. And for this case, the numerator is what we call the sum of squares between groups. Then we find the within group variance, which is given by the summation of the sample size minus 1. Then we multiply by it by the individual variances of the samples. So that here the numerator is what we call the sum of squares within groups. So to get the test value, we divide the variance between group variance or the between group variance. We divide the between group variance with the within group variance, and the degrees of freedom are degrees of freedom numerator, which is k minus 1, and I mentioned that k are the number of groups, and then the degrees of freedom denominator will be the total population minus the number of groups or number of samples. So then we make a decision and summarize our results. So I have an example to help us have a deep understanding of what is above. So a researcher wishes to try 3 different techniques to lower the blood pressure of individuals. The subjects are randomly assigned to 3 groups. So the first group takes medication, the second group exercises, and the third group follows a special diet. After 4 weeks, the reduction in each person's blood pressure is recorded. And at alpha is equal to 0.05, I want to test the claim that there is no difference among the means, or there is no difference in the effectiveness of all the 3 techniques. So we are given the 3 groups. So the first one is medication, exercise, and diet. And we are also given the sample means for medication. The sample mean was 11.8. Exercise is also given, and diet. Then we are also given the individual variances for each sample or for each group. So for the medication, the variance is 5.7. For exercise, the variance is 10.2, and for diet, the variance is 10.3. So our first step is to state the hypothesis. So our null hypothesis will be that the means are the same, and then the alternative or the claim will be that at least one of the means is different from the others. So step number 2 is to find the critical value, and we use the F table. Since we are looking at an F distribution, remember we have 3 groups, so our K is 3, and then N, or the total population, we count each variable in the entire data set, so that will be our total population. So degrees of freedom numerator K minus 1, our K are the groups, so there are 3 groups, minus 1, which will give us 2. Then degrees of freedom denominator are total population minus the number of groups, so that will be 15 minus 3, which will give us 12. So we go to our F table, the one with alpha of 0.05. So we look for, these are degrees of freedom numerator, and that was K minus 1, so which is 2. And then degrees of freedom denominator were 15 minus 3, which is 12. So our critical value is 3.89. So, which is here. So step 3, we compute the test value using the procedure in the previous slide. So we start by getting the grand mean. Now the grand mean will be the total of all elements in the entire data set divided by the total population. So if we add from the first element 10 to the fourth, we shall get 116, then we divide by the total population, which is 15. However, please note that when the sample sizes are the same, when each, for example, in the scenario here, when each group has the same number of elements, the grand mean can still be the summation of the different means divided by the number of groups, but that only works if the sample sizes are the same. So our next step is to find the between group variance, which is given by the summation of the sample size, individual sample sizes, times the square of the difference between the individual means and the grand mean divided by k minus 1. So here we have our n. So we have three groups, meaning we are going to work to add up three groups. So our first group, the sample size is 5. And then the individual mean for that case was 11.8, which is here. And then the grand mean we've got is 7.73. So 11.8 minus 7.73. So we square, and then the value of the square, we multiply it by 5. You remember, body must deal with the bracket first. Then if you have an order or a power, and then after you can do the multiplication. So we do the same for the second group. The individual mean is 3.8 minus the grand mean, which is 7.73. We square and multiply by our sample size, which is still 5. So here the sample size is constant, it is 5 because it is the same, it is 5 all through. But in case there is a variation, please maintain what the sample size of the sample of that particular group. So what we get, if we divide it by 2, we shall get our between group variance as 80.07. Then we find the within group variance, which is given by the formula, the summation of the individual sample size minus 1 multiplied by the individual variances. Now the sample size for this particular example, it is 5 all through. That's why we have a 5, and a 5. And then the denominator also has a 5. But n should represent that specific sample size for each group. So for the first group, we have sample size is 5. So sample size are the different elements in the group. So that will be 1, 2, 3, 4, 5. So our n is 5. And for the second is also 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it is 5 all through. But then there are cases when the sample sizes are different. So I don't want you to just know that it is constant. So here it is by coincidence that we have a 5 all through. So the first group, we shall have our n minus 1, which is 5 minus 1, then times the variance, so which is 5 minus 1. Remember, the square means variance, so you don't have to square the difference. Maybe if they had tricked and given us standard deviation, then that's when we would square. So this square just means variances, so we just multiply by the variance, which is 5.7. Then the second sample, the second group, our sample size is still 5 minus 1, and the variance was 10.2. The third one, the sample size is still 5 minus 1, then the variance was 10.3. So if you do the addition and subtraction, multiplication and addition, we shall come up with this and then divide it by. So the summation of n minus 1, so we start, the first group was 5 minus 1, the second group is also 5 minus 1, the third is also 5 minus 1. So our within group variance will be 8.73. Now the formula for getting the test value, we divide the between group variance with the within group variance. So our between group variance was 80.07 and the within group variance is 8.73, giving us 9.17. So you can see that these are big, and then the f-test value is also far greater than 1. So what do we do? And on top of that, the test value is way greater than the critical value, which was 3.89. So therefore, we are going to make a decision, and that will be to reject the null hypothesis. Since our test value is greater than the critical value, or the f-test value lies in the critical region. So, and therefore, there is enough evidence to reject the claim that the claim and conclude that at least one of the means is different from others, or at least one of the uh, different techniques of lowering blood pressure is more efficient than the others. But like I mentioned, this F test only tells us that there is a difference. But if you're interested in finding out which technique is more efficient than the other, then you employ the other tests, such as the Turkey test, to find out which one is more efficient. So here we've only found out that at least one of them is more efficient than the other. Other means are one of the means is different from the other. Thank you so much. Please practice this. Read. In our storyboard, there is a list of references, so please read and make yourselves familiar. Stay well.